Okay, good morning, afternoon, or evening, depending on what time it is when you're watching. We're going to start Unit 2 today. As you probably can tell, I'm updating this year for Unit 1 and 2. Won't do it for the whole course, so I think Unit 3, 4, and 5 will still be a couple years old. Maybe I'll get to it later on, but this is our second unit now, trig. So the first unit was about 10 days or so, 11 if you count the exam day. A couple of weeks, over just over a couple of weeks. This one will be approximately the same length, and we use a lot of trigonometry. So sine and cosine laws are the main focus here. But in order to get to that point, we have to know some previous knowledge and learn a few things. And the very first day, that's today, day 1, we're going to be looking at what a standard position angle is. And then we're going to look at special triangle ratios, what a reference angle is or are. Then we'll look at the quadrant and the positions in the quadrant. And then I'll be doing some examples as we go through that. And then I'll leave you with some practice. I think this one will be a little longer, maybe 35 minutes instead of around the 30 that we've been managing to stick with in the first few videos, but we'll see how it goes. So let's start off with what a standard position angle is. So if we have the quadrants, and I'll just put quadrants in here like this. Okay, so first of all, a little bit about the quadrants. Okay, if we have, let me get my marker out here. If we're starting with the quadrants, let's get my marker set up. There we are. Okay. Okay, so if I start here, we call this top right one here quadrant 1. And usually by convention that we use Roman numerals. Quadrant 2 is the top left one, bottom left one is quadrant 3, and quadrant 4 is the final one over here at the bottom right. Okay, and if we are taking and we're making an angle in here, these are our quadrants. If we're making an angle in here, there's a couple of different ways. A standard position angle always has its initial arm on this positive x-axis. If this is x here, and this is y, and if I take and draw a ray here for the initial arm, let's do it in blue. Okay, so that's the first point. Okay, a standard position angle okay, so the first point is the initial arm, starting arm if you like, is on the positive x-axis. Okay, I should probably skinny that up a little bit, a little easier. Okay, so that means like that. Okay, and then the terminal arm will go and connect at the origin. So we'll put the terminal arm as the green one, let's say. So let's just make one like this. I better put it as a ray. Okay, and so 2 the terminal arm connects with the initial arm at the origin. Okay, so there we have. Now let's say that this one rotates. We'll use purple here. Goes this way. We consider that measurement to be positive. Okay. And if it goes the other way, which I'll use a different color red here, goes, if you measure down and around like this, we consider that a negative. So a negative angle rotates down, rotates clockwise, right? Downwards from that x-axis, we'll say, or if you know clockwise direction, right? And then we can say for the purple one, we can say the positive one, positive angle is one that rotates upwards from the x-axis. And we can say that that's counterclockwise. Okay, so that's pretty easy. Come in if you want. I can just pause. Okay, oh, they don't want to. So that's pretty easy to do. So just remembering that for a standard position angle, you have to have the arm on this x-axis here. And if you're going to be measuring positive, you go up from it wherever the terminal angle is, and down if you're measuring negative. And these are two different measurements that mean the same angle. And also you have to have them connecting right at the origin. They can't just be anywhere. So if we take a look at it, we know from experience, if I go to black here, and circle knowledge that we have, that 0 degrees is up here, this is 90, this is 180, 270, and then it comes back to 360. Okay, now if they were going to do one that went more than 360, they would wrap it all the way around. So if we had one that was, let's say we'll do one in black here. So if I wanted to go to this and have another angle that's this angle plus 360, I would do it like this. I would go all the way around and then back. That's what it would look like, except I'd probably put it closer. Okay, I'm going to erase that because I don't want to leave that in there, but that's possible as well. To have angles that rotate more than one circle degree. Okay, so angles that are not in standard position. Okay, if I just drew another set here. Oops. Let's go with just a plain old one here. There we go. So, if you have something like this, let's get some angles here. Like if you have an angle that looks like this, that's not in standard position. If you have an angle that looks like this, even though it's but it's starting on the y-axis, not the x-axis. So, oops, sorry about that. So if you get these weird looking angles like that, these are angles, but they're not standard position angles. Okay, so these are not standard position. Okay, so that's our first topic. Okay, the next thing we're going to look at is let's see, what is it here? We're going to look at reference angles. Okay, they follow along with standard position angles. Okay, so let me just flip ahead to the next page for reference angles, and we'll take a look at what reference angles are. So if I were to say, what is a reference angle? Okay, it's simple. It's, again, an angle that is in a particular quadrant where the initial arm is always on the x-axis, okay, and, is measured to the terminal arm. Basically, is what it is. I'll type that in here. The angle, or an angle, pardon me, in a quad, we'll say quadrant, but I'll say a quad for short, where, right, the initial arm I in there is on the x-axis of the quadrant. We'll put that in brackets, of the quad, and is measured to the terminal arm. I'll show you what I mean right away with a picture. What does that look like if we do an example of that? Well, let's draw in our quadrant again. Okay, and each quadrant will have its own reference angle. Quad 1 will have the same, the standard position angle and the reference angle will be the same. So let's do, I don't want an arrow there. I want just a plain old. Okay, let's get our quadrants here. Okay, we should always, when we're doing this, keep in mind we should label our X and Y's. So if I take this and I just label it up with the marker here, so that we know. So if we were to have, let's do different colors here. Let's go, if I were to have an angle of 40 degrees, let's use, okay, now this is my initial arm right here. Okay, so if I were to say that this angle here, let's make sure that I use the right color here. Okay, so that's theta, say, is equal to, I don't know, it looks like 50 degrees. So if we were to do, that's the angle that we have. Now, what's the reference angle? Well, the reference angle is actually the same because here's the initial arm. It's on the x-axis in quadrant 1. So in quadrant 1, the reference angle, which we'll call theta r, is equal to 50 degrees. Okay, let's do another one here. Let's say that let's go to the second quadrant. So I'll draw it in blue with the arrowhead here. Okay, so let's say that we have this one here, and that this whole angle, which I'll do in blue here, let's get in it. So that this whole angle goes all the way like that, and we know that that theta in the second quadrant, that's why I'm writing it over here, is equal to, that looks like about 20 degrees. That's 90. So let's say 110 degrees. 110 degrees. Okay, so where's the reference angle? Well, the reference angle is right here. This is theta r. Well, if this is 180 degrees over here, we know that this is 90, this is 0, and this is 270. You can figure out what the reference angle is by going 110 degrees. Actually, that's more than 110. Let's put it at 120. Sorry, guys, because that's 110 would be a 10-degree angle. I'll move it over so it's a little bit better. So let's say that this was 120 degrees. And that's theta. So if this is 120, okay, so that's about a 30-degree angle there, 90 and 30 degrees or so. Well, what's left, if this is 120, if we subtract 120 from 180, we've got 60 degrees. So our reference angle would just be 60 degrees. Okay, a reference angle in the third quadrant. If we do one in the third, why not? Okay, let's actually draw it here. So if I did one here, okay, the angle, let's say that we had here, all the way around like that, let's say that that was 220 degrees. That's fat. I hate this thing being set automatically on the mid one there because it just makes a mess. Let's use the skinny. Okay, so let's say that that angle is equal to, let's say it is, well, there's 180. Let's say that that looks about to be 210 degrees. Well, 30 degrees there. So our reference angle this time is just from the 180 degree down. So that's going to be our theta r. The reference angle is going to be this small angle here, which will only be 210 minus 180, 30 degrees. So the reference angle is 30 degrees. The actual angle is all the way around to 210. And the same thing would happen here in the fourth quadrant, except you would be minusing from 360 down here because this would be 360 over here. So if you had, well, we might as well just do one in red, I guess. Won't take us too long. So if I just do a red arrow here, that's not red. There we go. Let's put it like this. Okay, let's say that in that one, as we go all the way around from here to there, let's say that that angle, which we call theta there, well, that looks to be about 15 or so. So let's say, what would that be? 345 degrees, we'll say. So if this is 360, that means the theta reference, which would be just this one coming down like that, would be 15 degrees. So the reference angle always come up from there, down there, up from there, down there, always with the x-axis being the starting point in the quadrant. And that's reference angles. So that's our second topic. So we want to go into special triangles now, like special ratio triangles. And then we'll look at just a couple of questions. And I'll give you some practice. Okay, so let's go ahead. And we'll do this on the next page, I think. Why not? We got lots of space here. Okay, so we're going to look at special triangle ratios. So, and then we're going to, and there are trig ratios that go with it, okay? Okay, so I'm going to draw the first one I'm going to draw is the 45, 45, 91. So if I just get a square out, and then if we cut this square directly in half, doesn't matter which way, like this. And if we said that this was 1 here, and this was 1 here. Well, we know that from Pythagorean theorem, if this is a right angle, this would be 1 squared plus 1 squared equals c squared. So this 1 squared is 1, 1 squared is 1, 1 plus 1 is 2. 2 equals c squared, square root of 2 equals this. Okay, and if this is 45 degrees, and so is this one, we can come up with the ratios. Sine 45, its ratio is always 1 over root 2. Okay, because sine we know is opposite over hypotenuse. Okay, and if we do cosine 45, that's adjacent over hypotenuse. That's the same, but it's just this one instead of that one. So that's adjacent over hypotenuse. And the last one, of course, if we have tangent of 45. Okay, tan of 45. Well, tan is opposite over adjacent, 1 over 1. So those ratios exist always within a 45 degree. So if you have a reference angle that's 45, you know the tangent of it is 1. Or the cos. Now you could get these into decimal numbers as well. I think 1 over root 2 is something like decimal 0.7, something 0.1 or whatever. But these are in exact form. This is called exact form when you use roots and fractions. Okay, the other one that we have is the 30, 60, 90 degree triangle, and we get that one from an equilateral triangle. So if I draw that here, see if we can get an equilateral triangle. Okay, like that. And if I cut this equilateral triangle directly down and bisect the base of it with a so that's directly like that. And we take a look at a half of it so that we know that there's 9. So this is 60 degrees and this is 30 degrees. We get a couple of ratios with 30 degrees and 60 degrees. Now, if we assume that it's an equilateral triangle, we say this is too long, this is too long, and this is too long. So this would be 2, 2, and 2. So we're taking half of it because we're bisecting it. So that's a 1. And again, the same rule. Okay, 1 squared plus b squared equals 2 squared. So 1 squared is 1, 2 squared is 4. And we have to subtract because this is the hypotenuse. So 4 minus 1 equals 3, and the root of 3 would be what b squared is. So that's root of 3. So our ratios here for tan 30, cos 30, and sine 30 can be calculated. Tan 30 is opposite over adjacent. So here's 30, opposite over adjacent, or opposite, pardon me, over adjacent. Opposite over adjacent, 1 over root 3. Cosine is adjacent over hypotenuse, root 3 over 2. Okay, and finally the last one, sine is opposite over hypotenuse, 1/2. Okay, we can also do the 60 degree angle as well. We can go tan 60, cos 60, and sine 60. So now we have to look at this angle down here. So tan is opposite over adjacent, root 3 over 1, which is root 3. Okay, cos of 60. Cos is adjacent over hypotenuse, so it's 1/2. And sine 60 is opposite over hypotenuse, √3/2. And those are the ratios within that. So those are the exact values for those trig ratios within those special circles. Do you have to memorize those? No, you can figure them out. A lot of times, if you're in my room here, there's usually posters on the wall that have that. Or if you want, you can throw it on a formula sheet if you're not sure you're going to remember it. It's not something that you need to memorize. But if you can derive it from this or this, that's good too. Okay, so that takes care of. Let me take a look at my time here, how we're doing. Okay, we're sitting around 25 minutes, so not bad, 26 minutes. Okay, so the last thing I want to do then is finding reference angles, doing an example of that, and then talking about the cast rule in quadrants, and then I'll give you some practice, okay, from the text, dealing with all this kind of stuff. So let's start off with the cast rule when you're working within a quadrant. So if I draw the quadrants, okay, and we look at the quadrants here. Let's get my marker out here. So this is 1, this is 2, this is 3, and this is 4. So if you're thinking of this has a positive x and a positive y. This one has a positive y and a negative x. This one has a negative y and a negative x. And this is a positive x and a negative y. Okay, so what happens then is that we have something called the cast rule. Starting at the bottom. And this means that all trig ratios are positive. And we'll develop y as we go farther in it, because we're going to figure out that sine is x over r being the hypotenuse, or y over r, pardon me, and cosine will be x over r, and things like that as we go on in the unit. So all are positive here. Here it's just sine that's positive. Here tangent is positive. And here, of course, cosine is positive. Otherwise, the other two are negative, the other two are negative, and the other two are negative. And we'll use that a little bit as we go. So let's do an example of finding a reference angle or something like that. Let me pause here and just double check to see if I need to hit any more examples before I'll give you practice, and I'll be right back with you. Okay, no, we're just going to need to do one example here to just kind of drive home reference angles, as I'm going to do some more work next class on the tougher stuff. Okay, so let's just do one example here, and then I'll give you some practice. Okay, so let's say the question is, find the reference angle for each. Now that you can do the backwards thing as well. They might give you the reference angle, and you've got to find the possible angles, and there's 4 possible angles if you're given one reference angle, because there's 4 different quadrants. But the most common question is something like this. Find the reference angle for each. So let's say we had u equals 240, And let's say we did W equals 311. Now, as well, they might ask you for sine of 40 if it has a reference angle that is one of those special triangles, but I don't think that'll come till we do it later, like in the next section. Probably in the next lesson. So what we do is we draw our quadrant, we draw our angle. So W is 240. So if we're doing this one, X and Y. Okay, so 240, this is 180 over here. So let's just put it in here. (240°). So that means theta R, that's going to equal 240 subtract the 180 that's up here. Remember, that's 180. This is 90, 270, 360, 0, and 360. So the reference angle there is equal to 60 degrees. So that's one of the special triangles. So if I ask you, what is the sine of that? You would go, oh, well, sine of 60. So you go back and look at your special triangle. Well, sine of 60 is root 3 over 2. And Castrol, C-A-S-T, that would be negative root 3 over 2 because it's not in the all or S quadrant. But don't worry too much about that until we'll get into that full on in the next area. Okay, we'll do one more here. 311, somewhere in here. (311°). Let's make it skinnier. It's harder to read. So this theta R equals, so this is 360, subtract 311. That equals 49 degrees for our reference angle. Okay, so for today, I'll just mainly focus on reference angles and angles in standard position. So this is on page 83 and 84. And you can do 1, 2, 3, 4. You don't have to necessarily do all of them in there, but there's only 2 or 3 in each, and 7. Work on those, and then next day we'll get into expanding on sine and cosine in standard position, and we'll be getting into how you find what's called exact values and things like that. Okay, so I'll let you be there. That's been a bit longer than we have been doing. That's about 34 minutes. So we'll see you tomorrow. Good luck. If you have any questions, don't be afraid to ask.